All right, section 8.3 is measures of dispersion, range, variance, and standard deviation. In the last section, 8.2, we talked about kind of measuring the center of the data. Showed the exact middle number, the median, and the mean. So we're talking about the kind of the middle. Now we're talking about like how the data is spread out. So there's different ways to measure how the data is spread out. The first way is just the range, which would be the largest number, right, minus the low. So if the highest score on the quiz was a 95 and the lowest score was a 60, then the range would be 35 points or 35%. So you just do the high minus the low. That's easy. Okay, variance. We talked about population. Population is the whole thing, every single person or every single thing, where a sample is just part of the population. So there's two variances. Sigma squared is the population variance. So this is kind of a measurement of how it spreads out, and I'll show you how to calculate it here in a minute. And then S squared is the sample variance. So basically, if you like, you think about how does it vary, how is it spread out? So that's in dispersion is like how the data is spread out. Okay, they use those fancy words, but that's kind of what it means. So standard deviation, I'll just do it this way. Standard deviation is the square root of variance. And you'll kind of see why we do this when I go through the example. Bless me. Sneezy, sneezy, sneeze. All right, so we're going to calculate our first population standard deviation. And this is going to be very, very simple on this next slide here. So we're going to calculate sigma squared, the variance, and then we'll take the square root to get the standard deviation. So that's how we do this. So here's our numbers. These are all the numbers. Okay, 10, 8, 6, 4, 2. So there's 5 numbers. So there'd be like 5 people in your class. And one person got a 10 out of 10 on the quiz, one person got an 8 out of 10, a 6 out of 10, a 4 out of 10, a 2 out of 10. And that's it. All right. So what we have to do is we have to calculate the average first. So step 1, what is the mean? And this is a population, so that's mu instead of x bar. So mu is equal to, add the numbers together, 10 plus 8 plus 6 plus 4 plus 2 divided by 5 numbers. So that would be 20, let's see, 20, or yeah, 20 and then 30. So the answer is 30 divided by 5 is equal to 6, which totally makes sense because it's perfectly spread out here. So 6 is the middle number and 6 is the average. So I just added the 5 numbers together, divided by 5, and I got 30 divided by 5 is 6. All right, so what we're doing is we're comparing to the average. And the way we compare in math is subtraction, right? Like, you know, so-and-so makes $16 an hour, and so-and-so makes $12 an hour. Oh, that's $4 more, right? So we compare all the time with subtraction. Like, I'm 3 inches taller than this person. Well, how did I know that? I subtracted. So we have to compare. So we're going to do x minus mu. So I guess I'll put mu in here. And they're all 6. So we subtract, and we get -4, and we get -2, and we get 0. and then we get 2, and we get 4. All right. Now, when you subtract, sometimes you're going to get positive numbers and sometimes you're going to get negative numbers. So what we do to compensate for that is we square it. So our next step is x minus mu squared. So negative 4 times negative 4 is 16, 4, 0, 4, and 16. All right. I guess I added this column here. This is a dead column. I don't need this column anymore because I added that column there. So anyway, so I could have done this column, that column, but I just cut that column in half for some reason. So here's the formula. So step 1 was to calculate that. I wrote it in here. And then this was step 2. This was step 3. All right. Now, step 4 is to calculate sigma square. So we're going to calculate the variance. So step 4, variance. So the formula for variance, sigma squared, is equal to the sum. So this right here is the summation sign. So this means sum. It's a Greek letter of the alphabet. We're going to add up all of the x minus mu squareds. And then we're going to divide that by n to kind of find the average of that. All right. And that's all you do. So we're going to add up this column here. So it's 16 plus 4 is 20, and then that's another 20. So if we add up this column, we get 40. And then there's 5 numbers. So 40 divided by 5 is 8. So sigma squared is equal to 8. So the standard deviation is the square root of the variance. So I just found the population variance, so I take the square root now. So the square root would be sigma is equal to the square root of 8, which is second square root of 8, 2.83. All right, so that's how you calculate the population standard deviation. So what is this telling us? This is telling us it's a tool for measuring how data is spread out. So let's say this is an IQ example. So the average IQ is 100 with a standard deviation of 15. So standard deviation is like, it tells you how big something is. Like we know an inch is about yay big, right? So it tells you how far a distance is. Well, one standard deviation is 15. So I go over 15, and that would be 115. So this is like 0, and this is 1 space over. So 1 standard deviation over is 115. So you could say if you have an IQ of 115, you're 1 standard deviation from the mean. So this is the mean. This is the average IQ. And then you go over 1 more tick mark, right? 2 standard deviations, that'd be 130. So you'd be like, oh, I have an IQ of 130. That means I'm 2 standard deviations from the mean. So it just tells you how the data is spread out. So if you go to 3 standard deviations, right, then you are at 145. So what happens is the farther you get away from the middle, the harder it is to find these people, right? So most of us kind of fall in towards the middle. So then this way would be negative 1 standard deviation, or back 1 standard deviation, and this would be 85, and then back 2 standard deviations would be 70, and then back 3 standard deviations would be 55. So the farther you go to the left and the right, the harder it is to find the people. The probabilities of finding those people are harder. So most of us fit in here. So standard deviation shows how data is spread out. In our example, the middle is 6. So if you have 6 in the middle, right, then you would go over 1 standard deviation. You'd be at 8.83. So this would be 0, and this would be 1 standard deviation. It would be 8.83. I messed up my 8 there. All right, so that's the way that works. Now it's harder to add, and subtract 2.83s, but that's how the measure how the data is spread out. And this kind of tells you how well the data is packed together, or like I said, spread out. Okay, what's a z-score? A z-score is a way to tell how far you are from the center. So what you do to calculate a z-score is you do whatever your individual score is minus the mean divided by the standard deviation. All right, so let's say you had an IQ of 120. So how do you fit in there? How many standard deviations you are from the mean? So your score is 120. We said the average was 100, right? And the standard deviation is 15 for IQ. So we get 20 over 15. So we divide that with a calculator or without a calculator. 20 divided by 15 is 1.3, repeating. So you would say, oh, I'm 1.3 repeating standard deviations from the mean. That's my z-score. So if you were exactly at 130 minus 100 divided by 15 is 130 divided by 15, which is 2. So then you're exactly 2 standard deviations from the mean, which matches my picture here, right? 130 is 2 standard deviations. So these numbers up here are really the z-scores. Okay. The next slide is the 5-point summary. So the 5-point summary is basically the box and whiskers. The box and whiskers graph that you've made in the past before. So the first thing you do is you make a number line, and you have to put a scale on there that matches the data. So if you put 0 down here, right, and you count by 5s or something like that, 5, and you want to make sure that it's spread out perfectly, even 10, 15, and 20. If you want to count by 1s, you could count by 1s, okay? So basically what you do is you make a mark for the low, and you put your box and whiskers above. So here's a 1, okay, so that's the low. And then you put the high, that's a mark. So 19 would be like right here. Okay, so there's the low and the high. Then the next thing you mark is the middle number. So you go 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 1, 2, 3, 4, 5. So there's 10 numbers here, right? So 1, 2, 3, 4. Yeah. So there's the center. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So when there's no exact true center, you do the average of the two middle numbers. So 10 would be the median. So 10 is the median. So you mark the median and the high and the low. So that's 1, 2, 3 marks. Then you find the median of the lower part of the data and the median of the higher part of the data. And that's called the first quartile, F-I-R-S-T-Q-U-A-R-T-I-L-E, the first quartile, and the third quartile. Okay, so the first and third quartile are the medians of the upper and the lower parts. So if I look at this data right here, I have 1, 2, 3, 4, 5. So 5 would be the median of the lower part of the data. So I mark 5. Okay, and then 15 would be the low of the median of the upper part of the data. So this is Q3, and then this is Q1. All right, so we have the low, we have the high. The first quartile is the middle of the bottom. The third quartile is the middle of the top, and then we have the actual middle. Then what we do is we draw a line through all of these lines that we just made, And in the middle, we make a box. So there's the box, like the center of the kitty cat, and then there's the whiskers coming off of it. What this does is it splits the data up into quarters. So 25% of the data is here, 25% of the data is there, 25% of the data is there, 25% of the data is there. So it's split it up into quarters. So from here to here is Q1. This is the median, which is really Q2, right? Because it's the middle, that quarter, and then Q3. It's like we take a log and we've split it 1, 2, 3 times. We made these 1, 2, 3, 4 quarters. All right, so that's how we make a box and whiskers. We identify the low, the high, the middle, the median, the first quartile, which is the middle of the bottom part of the data, and this quartile, which is the middle of the top part of the data. So that's a 5-point summary. So there's 5 points. 1, 2, 3, 4, 5. All right. Percentile. What is a percentile? So a percentile is the percent that is ahead of you. So the 80th percentile means that 20% of the group is ahead of you. All right. So let's say you've taken a test and there's 275 people that have taken the test. All right. So there's 20% ahead of you. So I'm going to do 275 times 0.2. All right. So we type that into the calculator. 275 times by 0.2 is equal to 55. All right, so there's 55 people ahead of you. So there's 55 people ahead of you. Where are you? Well, if you count down from 1 to 55, you'd be in 56th place. So that's the meaning of a percentile. All right, so let's go back through this again. So the section before we were talking about where the middle was. Now we are talking about how the data is spread out. All right. So a small standard deviation means everything is like compacted towards the middle. A big standard deviation means things are really spread out. Standard deviation is the square root of variance. Okay. Oh, I forgot to give you a formula down here. This is population standard deviation. If you're asked to find sample standard deviation, you have to do a slightly different formula. And it would be S squared is equal to, you sum up the same stuff as before, x minus mu. What's actually x minus x bar, because it's an average, not, or it's a sample average. So it's x minus x bar squared divided by n minus 1. So to compensate for the fact that you have a sample, they do this thing where you do an n minus 1 instead. So it's the same thing. Now remember, mu is the population average. X bar is the sample average. So it's x minus x bar squared. So you figure this out exactly the same way. You add it all up. The only difference is right here we would have said 40 divided by 4 instead of 5. And then you take the square root, and then you have the sample standard deviation. So I forgot to add that in there. Okay. So what is a standard deviation? It's comparing to the middle. So we do the subtraction. We add up we square it to get rid of the negatives. We add all that up, and we divide by how many things we have, and we get a number. And then the square root of that number is the standard deviation. Standard deviation is a tool to measure how things are spread out. So the standard deviation for IQ is 15, so we go over one space, that's 15, we go over another space, that's 30, another space, or backwards spaces. And that's how these numbers up here represent the z-score. The z-score formula is score minus mean divided by standard deviation, and that tells you the z-score. The 5-block summary is the low, the high, the middle of the bottom, the middle of the top, and the middle. And then we draw and box in that middle part, and that's the middle 50% of the data. And percentile is the percent of people that are ahead of you. So if you're in the 80th percentile, that means 20% are ahead of you. So if you have 275, 55 people are ahead of you, so you're in 56th place. Ta-da! Lesson 3.